Okay. So with any of these, it's always that same model. It's always that same template. It's part over whole as your template. Something over something, which we've got to figure out from the word problem. And then this last column is always your percent, which is going to be something over 100. I always think percent's the easiest because if they give it to you, look for that little percent sign. You see it? Oh, there it is. You can put it in. That's one whole ratio. Done. Now we've got to decide what to do with 120. You got to kind of think through it. Is that 120 the part, or is it the whole? Because where you put that number will make the difference of whether you get the question right or wrong. Meals.
Whole.
How did you know it's whole?
Is it set up?
Yeah, look for those keywords. Set of, whole thing, whole class, whole bag, 120. Now, in this particular missing value, you can make a direct connection between where? 100 and 120 or 5 and 100? Well, yes, it works out nicely here. Times what? Then you got to say to yourself, okay, what number times 20 will make 120? Or you can always work backwards and divide. What do you get? 6 marbles are black. Most of you were fine with that. Got it. And then there were a little bit more difficulty on the back, but it really wasn't too bad. Every time you show the work, like when you take your quiz or do your exit ticket, show the model, because if you put the numbers in the right spot, you're going to get some credit. So you could, but you don't need to, because it's an extra step that you really don't need. You could, absolutely, and then it's times 6 going this way, and you would do the same thing times your 1, but you could. Okay, so now go to this. Here's where you do need to scale down. The model's still exactly the same as it always is. Part over whole. That's your template. Ratio and percent. Do they give you a percent for this question? Do they give you a percent? Do they give it to you? They do not. They're asking you to find what percentage. So we know that this is going to be missing. That's what we're trying to find. But this always stays the same, so it's something over 100. They have to give you the part, and they have to give you the whole if they're asking you to find percent. Okay, you can't have 2 missing pieces of the model. It won't work. You need 3 out of 4 always. So 48 out of 120. Well, that's a complete ratio right there. So, yep, 48 being the part, 120 being the whole. And then here's where some of you got stuck. If you got at least this far, you're well on your way. You're in good shape. Because 100 can't go into 120 evenly, and 48 can't go into 120 evenly. So you've got to do something. If you're smart and you know your multiplication facts, and you know that this times 1.2 will get you 120. Some of you are at that level where you can do it. And then you've got to do 48 divided by 1.2, but some of you are able to do it. But if you don't want to go that route and you like numbers like me, nice and even, where things go in evenly, nice and nice, you got to scale down 48, 120 until you find something that will go into 100. Did you scale? What'd you do? All right, you did multiplicative structure, right? Let's try a scale. That's not scaling down, though. That's multiplicative structure. Scale it down, and listen, if you don't know what the value is, at least try to cut it in half and see if it'll go into 100.
I got 2 over 5.
All right, so if you scale it down, let's do this. I'll show you the whole process. 48, 120. Let's say you don't know how to get to the value, but you know. Remember we did divisibility rules? It's so important because if you can find one number that goes into both, you can at least start with that. They're both even numbers, divided by 2. And you'll get 24 over 60. Still doesn't help us because 60 can't go into 100, nor can 24 go into 60. But they're both even numbers. So let's break it down again. What do you get? Help me out, Ryan. But 30 still can't go into 100. 12 can't go into 30. So now, let's divide by 2 again. Why not? You could. You could. We'll get there eventually. You're right. We will. If you can see that 6 goes into both, we can. But let's say you don't see that. 15 still can't go in 100, though. Now you do what? Here we go. 2 over 5. And remember, value of the ratio is your best friend. Okay, go ahead. Stop me. What? Yes. Go. You can do that. That'll work too. That'll work too. Because once you get that 4/10, that 10 can go into 100. You're fine. You still scaled it. You scaled it down, but you scale it down to it's not the value of the ratio, but it is an equivalent ratio where that 10 will go into 100, and you can do that. Okay. If you scale down to the value, I'm not going to say always, but most likely, that value will go into whatever number you need it to go into. Now it's times 5 into 100. 5 times what makes 100? Times 20. Do the same thing here. And you get 40 what? Don't forget, we're trying to find not marbles. They're giving you the marbles. They're asking you to find the percent. 40% are green. Christian, how was that for you? Manageable? All right. Good. All right, going to teach you something new. Let me go back to my plan. I forgot. I think it's page 11. Page 10. Page 10. Same lesson. You gotta find it. So with the I know that's fine. I still do want to record. Let me pause it until I find the page. Okay. I'm hoping that this is not going to be more confusing than it needs to be. Before I go forwards, let me go backwards. When we did the 10 by 10 grids, and every block was worth 1%, the entire block would be how much percent? Yeah, you can say it out loud, 100%, okay? If each block was still worth 1, and they asked me to shade 17%, how many blocks would you shade? Yeah, 17. What if I now tell you that in that grid, the entire grid, think of it like a tape diagram, the entire grid now represents not 100, but 600. What would be the value? Remember, it's like trying to find the magic number. What would be the value of each block? Ryan? 6. Now listen, I could put 6 in every block. I'm not going to do that, but I kind of want you to visualize 6 being in every single block throughout. Okay? If they ask me to shade 17%, I'm still going to shade 17 blocks. Those 17 blocks are not going to be worth 1 each anymore. They're going to be worth how much each? 6, right? So just do this with me. Put a line through, or you could shade it lightly if you want, but I want you to shade 17 of them. All right, so let me see if this makes sense to you. Say you have 600 rocks. We'll do 600 pennies. 600 pennies. And I take 17% of her 600 pennies. How would you figure out how many actual pennies I have? She's got 600, and I'm taking 17% of those. What would you need to do to figure out actually how many pennies I have? Cars. Right. Because if she had 100 pennies and I took 17% and each penny is worth 1, I would have 17 pennies. But now I'm telling you that she has 600 pennies, 6 times more, and I take 17%. I got to take that 17%, or the 17 that I have, and multiply it by what number? By 6. I want you guys to do that and tell me what you get. All right. Nate, what do you get?
I got 100.
Did you get 102? Circle it. So again, 17% of 600, rocks, pennies, pencils, whatever it is that she has. If I take 17% of her 600, I would have 102 of those things. That's what the second half of this lesson is about. It's called percentage of a number. That number is no longer going to be 100, as you'll see. All right, well, what about 83%? Each block is still worth how much? 6, but I'm going to shade 83 of them. I'll tell you what, let's be smart. There's 10 shaded, 20, 30, 40, 50, 60, 70, 80, 3. Now what? Each block is worth how much again? So I'm going to do 83 times
6.
Do that. Tell me what you get. Sebastian, what'd you get?
498.
Did you get 498?
Yes.
Circle it. Ready? Watch. Part makes 100%. Part percent plus part percent. Whole percent. Ready? 102, is that a part or a whole? 498, is that a part or a whole? Part plus part makes whole. Okay? What if I tell you, see if you just kind of grasp the concept. What if I told you the whole grid is worth 200 and I shade 17%? Well, let me ask you this. What numbers would I multiply first? Madison. 17 times 2, because each block would then be worth 2 if the entire grid is worth 200. What if I told you that the entire grid is worth 1,000? And I shade 17%. Which would be? Might as well do it. 17 times 10, add a 0. 170. So you kind of get that down, right? But in the real world, when you do percent of a number, you're not going to have time to jot out 10 by 10 grids to figure it out. So I'm going to show you 2 more ways. Each way gets progressively easier. Method 2 is TRF, or TRP. Easier than shading grids, believe me. And the third way, which I think is the easiest, but I'll leave it up to you, is straight multiplication. Okay, so going to see how we could check our work. Well, I kind of showed you. Part 102 plus part 498 equals whole of 600. So you kind of add your 2 parts together and it's supposed to make the whole. That's method 1. I'm going to show you method 2, which I think you'll like better than method 1. Yeah.
I still don't get how it's part and whole.
If I shade the whole thing, how many units have been shaded? 600 is my whole. If I only shade 17%, that's part 102. I've shaded only part of it, 102 out of the 600. If I shade 83%, 498 part out of the whole 600 are shaded. If I add this part to this part, I get the whole, which is 600. not what I want. That's not what I want. Page 11, right? Well, where are we on 10?
Yeah.
Hold on. All right, it's the same problem. 17% of 600, 83% of 600, but I'm going to show it using TRP. What's my template? Always. Part over whole. Ratio and something over 100. Where does 17 go? Meals. Where does 17% go? Nick. Over the 100, right. Percent's always married to that last ratio. All right, 17 over 100. I got only one more other number, and that's 600. Is that the whole or is that the part? Dave, that's the whole, which makes sense because whenever you're trying to find a percent of the number, you're always, always, always trying to find the part. It's got to be a number less than 600. Watch this, ready? Watch this. Times how much? Times how much? Look at that. You're right back to 17 times 6 like you did with the grids. Okay? Because if you recall back in lesson whatever, boom, 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 back in lesson 10, I always told you the magic number inside of each box of a tape diagram is your constant. So 6 was in each box, and that's your constant. 17 times 6 is 102. Okay, let's set this up. Template, ratio, percent. Template's always what over what? 83 meals goes where? Always. Snake, what goes here? Top or bottom first? Where am I going? What value? Constant, never changes. Right back to what you did back in the grid sheet. 83 times 6. Look at that, 498. Easier than grids, right? Ready? Watch. Easy. Easier. Now I'm going to show you easiest. 617, which is the longer digit, which has the most digits. Always put the most digits on top. 17% as a decimal. Multiply it. Multiply and be amazed. What did I say? I said multiply and be amazed. You got to show your work. Little cheater. Well, I will show it to you because you got to move your decimal. Yeah, you have to move your decimal. Remember, like you do. It's good practice, right? A lot of oohs and ahs. Okay, if you do it correctly, but with proper multiplication, you get 0, 0, 2, and 10. But look, you got to move the decimal twice. 1, 2. All right. And not that I need to do this, but if you did 600 times 0.83, you'll get, I might as well do this. 18, what is it? 0, 0, 18, 0, 0, 0, 4, 8, 498. I think it's the quickest way to do it. But here's your beware, your little red flag beware. You gotta know your multiplication facts. You gotta multiply correctly. I mean, this is showing work if you want to do it this way. What makes this method the preferred method is you're going to get to eventually something like this: 18% of 25.2. If you try to do this as a TRF, it is cumbersome. It's going to be a lot of work. But if you know to take, most digits, 25, I got 3 digits, 25.2, and I multiply that by 0.18, and I multiply correctly, I'll get that. Okay? A percent of a number is always a number. It's not a percent. If you're trying to find, let's say, if I go back to this, 17% of 600, going back to the rocks and pennies, if Meals has 600 pennies, and I take 17%, how many pennies do I have? How many do I have? I have 102 pennies. I don't have 102%. I have 102 pennies. A percent times a number is a number. Okay? If Matty Stack has 10 pencils, and I take 50% of his pencils, how many pencils do I have? Gave you an easy one you can do in your head. I have 5 pencils. I don't have 5%. I have 5 pencils. A percent of a number is a number. Okay? All right. So here's what you're going to do. We're going to make this fun and exciting. Yes, we are going to differentiate. Different groups will be doing different things. Okay. If you are unsalted, you have to complete lesson number 26, page 12, which is that percent of a number. Like I said, you could do TRF if you want, but if you want to do straight multiplication, you can. You just got to show your work. Okay? All of page 12 is percent of a number. Then, page 15, question 3, it's the only one left on that page. And then you can do your exit ticket. And don't forget, we have a double period, so whatever doesn't get done in the next 5 minutes, we'll complete it after lunch. Okay? Advanced, you have a little wrinkle. Advanced, you're not doing 12 at all. You're skipping 12. You're going right to page 13. Same idea as what they're doing on page 12, but you're dealing with decimals, you'll see. Then, you've got to do page 14, 7 through 15, and it's a little contest, and I already think I spoke to half of you. You can work in teams of 2 because they are really hard questions. Very hard questions. But you got to really think for advanced, yeah. Well, listen, if you get done with everything, if you're not advanced and you just want to try and just kind of see that little contest thing, hey, more power to you. I'm not going to keep you from challenging yourself. But get everything done first, okay? Including the exit ticket. If everything gets done and you want to see what that advanced level group is doing, and you want to try it in groups of 2, go for it. You never know. Yes? I know. All right, so that's it. That's all I got for you. Group up and go.